Hey everybody, welcome to the Daily Space Weather. Thanks for tuning in, and congratulations on realizing that our channel exists. I'm your host Dan, aka smAsho, and we're looking at the sun here in 304 angstroms. A bunch of filamentary activity around the limbs of the sun, some weakening sunspot activity. Not a whole lot going on in terms of solar activity actually right now, despite there being some space weather on the way. We'll get to it. First, let's take a look at these coronal holes in the southern hemisphere. Coronal holes are spots of low plasma in the corona of the sun. So these areas here are areas of low iron content, and they are essentially low pressure zones as the sun is blasting solar protons into space out of these areas, the South Pole-oriented coronal hole systems. Here's 171 angstroms, another one of the ultraviolet emission spectra of ionized iron. Looking at the southeastern limb here, as there's some filamentary activity going on down there. Sunspot activity quite low, though. So we still do have a sunspot up here, sunspot 2822. And let's get into some more data. Here's what's going on in the solar system right now. Here's the layout of the heliosphere. Let's advance it 1 week. Approaching a full moon in a week. Here's a star chart. I like to use in-the-sky.org and face mine to the south, as I'm currently facing to the south. And if you're up before dawn, you may see Saturn and Jupiter on the ecliptic, which is this yellow line that we've drawn in, the path the sun will take across the sky. The 10.7 centimeter radial flux only at 73 solar flux units. And here that is in context. The black line here is the radial flux. The red line is the sunspot number. And the radial flux and sunspot number are directly proportional data sets. We are expecting a coronal hole wind stream as well as a coronal mass ejection strike. So I'm expecting the coronal mass ejection strike a little earlier on the 18th. NOAA is expecting it later on the 18th. I think it was moving a little higher speed than NOAA forecasted, but basically we agree on this. Also, a coronal hole wind stream expected to show up late on May 17th. And this is the Space Weather Enthusiast dashboard, by the way. You can check that all out by yourself. And let's check out global seismicity. What we're seeing is a lull in 7+ magnitude earthquakes. So the lull continues. There's the 90-day bar graph of major earthquakes on planet Earth. And here's volcanodiscovery.com's sort by magnitude page. So a number of 5 magnitude earthquakes have kicked off in the past 24 hours here. Let's get to a more comprehensive list on USGS. So not a lot of earthquakes overall, but several in the 5 magnitude range, it looks like, including a 5.2 at the Solomon Islands, a 5.0 at Papua New Guinea, followed by some aftershocks there. Also a 5.7 at Japan. That must be one of the largest of the past 24, if not the largest. And if we miss anything on our earthquake list, just leave us a comment and let us know. 5.3 at Papua New Guinea. As the earthquake drought for large earthquakes continues, the 7 magnitude earthquake drought. Let's check volcanoes. Dacono's erupting, flight level 070. It's producing a 7,000 foot plume of volcanic ash. Pacaya in Guatemala has dispersed its volcanic ash, according to satellite imagery. Sangay in Ecuador exploding, 20,000-foot ash plume there. Sabancaya in Peru exploding, 24,000-foot ash plume there. And Novato State Chilean through some explosive activity, reminding us that it's produced a 14,000-foot ash plume, which is probably too big to pole vault, so don't pole vault the caldera. Also, an interesting story here about Kilauea. Here's Kilauea at the beginning of the historic 2018 eruption. Here's Kilauea after a bunch of magma tubes collapsed. So here's the beginning of the eruption, and here's the meaty part of the eruption. You can see some new coastline got created there. Some new real estate formed in Hawaii. And what's up with it? Well, turns out that what triggers large-scale volcanic eruptions is caldera collapses. So I'm not the world's leading expert on volcanoes, but we do cover it as there are relationships between all of the geophysics going on planet Earth. Caldera collapse increases the size and duration of eruptions. So the Kilauea eruption was a historic one in that it was the biggest eruption in over 200 years. And I'm just letting the article scroll here. This is the SciTech Daily article. This is all based on a paper, which I think is linked at the bottom. There's also a video there produced by SciTech Daily. We'll leave that out. Go click on it yourself, scitechdaily.com. And indeed, there is a link to the Nature article as well. Another reminder to not pole vault the caldera. Please don't do so, folks. It's a little bit too sketchy to pole vault the caldera. Don't do the kind of thing that Steve Stimpak did by pole vaulting the caldera. It's an amount of danger you shouldn't expose yourself to. This public service message brought to you by smAsho.com. No solar flares here over the past 24. There's the 3-day chart of the GOES X-ray flux. And no spikes in the GOES proton flux. We're not really expecting any spikes there either, despite a coronal mass ejection on the way. Here's the GOES magnetometer over the past 3 days. And we saw some spikes early in the day yesterday. Now it's a little bit smoother. I would remind you again, there is plasma in between Earth and Sun. There is a coronal hole wind stream and a coronal mass ejection on the way. In that order. And next, let's take a look at some magnetic information. So here's the top view ecliptic plane field plot. Earth is solidly in a south pole-oriented current sheet shown here in red, the heliospheric current sheet. Next, the line-of-sight ecliptic plane field plot. The same data here from the line-of-sight perspective. Nothing to write home about there. And here is the line-of-sight coronal hole plot. You'll be able to see these south pole-oriented coronal holes here, shown in red, and also some movement of the sun's B field. So those blue potential field surface source lines that you see there, that's the sun's B field. And without getting super in-depth into that, we'll continue to show the detected sunspot groups. So here's the detected sunspot groups and the magnetogram. Sunspot 2822 still exists. 2823 is going to lose its name today. And this area up here, we thought it may get named 2824 yesterday. It did not develop. It did not continue to have ombre. So that's just a plage up there. We're about to drop down to only one sunspot, 2822. KP index, a measurement of global geomagnetism, currently at 1. So calm geomagnetic conditions there. And next, let's look at the real-time solar wind. We just saw a small uptick here. So we just saw the solar wind density come up as we're doing show prep. This may not have reached its peak yet. We'll be keeping an eye on it. And when I say eye on, well, the pun is intentional. We also saw the BTBZ, which is the top pane shift. That is the total field and the orientation to one of the poles of said field. That's the top white and red lines in the top pane. Current solar wind density, 6.12 protons per cubic centimeter. Solar wind speed quite low yet, 362 kilometers per second. This may be the early arrival of a coronal hole wind stream. We'll be keeping an eye on the signature, and again, it's looking like a coronal hole wind stream so far. So that's something to watch throughout the day. Next, looking at magnetohydrodynamic pressure in the Earth geospace. And we can expect to see the pressure increase here right at the end of the video. So you can see this very low pressure environment here for the first couple hours. This is showing you 4 hours of data. You can see here most of the pressure in the magnetotail region on the right, as opposed to the sun-facing side of the Earth on your left. And then here at the end, you're going to see the pressure come up a little bit there. A small increase in the pressure. Next, looking at geospace delta B, ground-based magnetic perturbations. And we do see some near the South Geomagnetic Pole, which is someplace south of Australia, as well as over the Canadian North Pole, less so over the Siberian North Geomagnetic Pole. Yes, we've got two. And you're currently living through a polar excursion. Congratulations on surviving so far. And by the way, we do regularly stream live to Twitch. And let's welcome our Twitch viewers. Welcome, Twitch viewers. We've brought you for the cosmology segment. And twitch.tv/smAshomash is the URL. Just bear with me 1 minute. And we'll get to the cosmology segment. Also, thanks to our new follower over on Twitch. And of course, we're also on YouTube. YouTube.com/smAshomash is the main source of our content. And I don't know why I don't have the right page open here. This is our YouTube homepage. YouTube.com/smAshomash. Don't forget to check out our playlists as well. YouTube.com/smAshomash/playlists. You'll find all kinds of content in there besides the daily space weather videos. And thanks to our new subscribers there, we're also on BitChute, exclusive content there as well. Welcome to the Neo Renaissance. Today's featured product is the Hell Dimension of the Year Tri-Blend t-shirt. If you'd like to commemorate the unanimously voted Dimension of the Year, Hell 2020, aka 1984, check that out. The link is right there on our homepage at smAshomash.com, the smAsho merch link. And today's cosmology segment is going to start out talking about the cosmic web. So what you're looking at here is an 11 million light-year length filament. So you're looking at very old data here. You're looking at something like 11 billion light-years away. And every one of those points of light there is a galaxy. And the galactic web, the cosmic web is, shall we say, interesting. So here's an article about this. First images of cosmic web reveal unsuspected presence of billions of dwarf galaxies. Why do they seem to have those filamentary appearances, folks? I've got theories about it. I won't talk about them in today's cosmology segment. We're going to keep it short as it is integrated into the daily space weather video today. What's up with all that hydrogen? Why is it almost entirely hydrogen? And what's going on in the galactic web? Anyway, this article on SciTech Daily, just a little kickoff for our cosmology segment. Today's random number is 949, which is a eclipsing binary. Here are some images of this. We'll tell you which eclipsing binary it is in a minute. First, some imagery. So this is it. This is the SDSS-9 optical bands. And an eclipsing binary is just two stars that are orbiting closely. in such an orientation that one star hides the other one. It makes for a very specific type of emission spectra. Here it is in infrared light on the 2MASS. And how about if we show you also on the XMM Newton multi-mirror project? There it is in X-rays from the XMM Newton. This object is actually VW Cephei. So there are the X-ray transient outputs from it, the last 16 years, the last 3 days, and the last 30 days of X-ray transients from VW Cephei, number 949 on the Neil Gorell Swift Bat X-ray Observatory. Today's quote random and quote object and eclipsing binary. NASA's astronomy picture of the day features this outskirt region of the Large Magellanic Cloud. I'm sorry, the Small Magellanic Cloud. It's NGC 602, a cluster of hot blue stars, as you can see, as well as some surrounding filamentary gas clouds. This galaxy back here is much more distant. The Small Magellanic Cloud located at about 200,000 light years distance. The astronomy picture of the day can be accessed at apod.nasa.gov. apod.nasa.gov. So a bunch of dust around some stars and some things that look like pulsar wind nebulae there as outputs from these hot, massive stars are affecting the filamentary clouds around them. And I won't go any farther than that, as I don't want to blaspheme anything. Next, looking at the most unprecedented high-resolution imagery of the Orion Nebula. What you're looking at here, this is another article from SciTech Daily. It'll also link to a paper. We'll get to it in a minute. What you're looking at here are orange boxes, which are the, quote, newborn stars. Red circles. The red circles are non-collapsing gas cores, and the blue plus signs are collapsing gas cores. And so you may want to check out this SciTech Daily article as well about how perhaps stars grow competitively. And so I'll let this one scroll. Feel free to pause the video if you'd like to read the article. We'll be here when you get back. Again, the orange squares are, quote, newborn stars, end quote. The gravitationally collapsing gas cores are the red circles, and the non-collapsing gas cores are the blue crosses. I think I had that backwards. So the collapsing gas cores are red circles, and the non-collapsing gas cores are the blue plus signs. Perhaps this gives us some insight into stellar formation, stellar evolution, etc. So check out the article here. It links to a paper as well from the Astrophysical Journal Letters. And that's today's cosmology segment. We hope you enjoyed it. And we'll have to say goodbye to Twitch. Bye, Twitch. We'll bring it back for the meteorology segment. Continuing on with the daily space weather, it's time to look at the realm of electrons. As the Earth is surrounded by bands of electrons, and the Van Allen belts are full of all kinds of ions and atomic matter, as well as neutral particles. So around the Earth are most of the time 2 Van Allen belts shown here, along with distances in miles. And here's the relativistic electron flux over the past year. You can find that at solon.info. Here's the 3-day chart of the electron flux, and we're in just normal ranges here. We're expecting an uptick coming soon. We don't see any charging hazards right now, and here's the forecast model. Noah and I both agree that, actually, I think tomorrow this is going to be up here. But we're expecting an uptick in the electron flux regardless. The green boxes are the forecast, and the yellow diamonds are the observation. Here's a visualization of this, the total electron content forecast. It's showing you the entire air column through both Van Allen belts up to your GPS satellite. And GPS air is most likely to occur around the equator at noon. We're seeing some chaotic Van Allen belts once again. Here's another diagram of the atmosphere. This is showing you distances in miles. And I'd like to attract your attention here to this F. That's the F ionosphere layer located about 300 kilometers. Here's a visualization of that, an ionogram, courtesy of Australian Government Bureau of Meteorology. This is actually 2 days of data. The total electron content forecast we showed you is only 1 day. We like to show 2 days of data here. As it's going to give folks a little better idea of what's going on in the ionosphere. And what you're looking at here, each one of these colored blobs, folks, are 1 megahertz of resolution. So the vibrational frequency of the matter in the ionosphere in megahertz, millions of vibrations per second. Here's the latest image coming in at 9:15 Universal Time, looking fairly normal there. And it's time to do meteorology. And let's bring back Twitch for the meteorology segment. First thing I'd like to note is there is a hurricane. I believe it's called a typhoon when it's at a place like India, but we see some very heavy winds on the west coast of India. So making landfall now. When I did show prep, we actually were above 70 miles an hour here. It looks like it's actually weakened just in the past few minutes. But there we do see some 82 mile per hour winds there right on the coast of India. A tropical typhoon making landfall at the moment. Let's zoom out to the rest of the eastern world to look at surface winds. There are the surface winds of the eastern world. Next, the jet stream. There are the jet streams of the eastern world. Probably the best meteorological snapshot you could take if you had to see only one data point to forecast global weather patterns. Here are the jet streams of the western world, rather. And we'll bring up surface winds for this side of the planet as well. There are the surface winds for Western Earth. Did I just completely fail to show that? Yes. Oh, great. Wonderful. Sorry about that, folks. Let's go back to show the data. There are surface winds of the west. Here are jet streams of the west. Here are jet streams of the east. Here are surface winds of the east. And here are hurricane force winds making landfall at western India. There you go, 80 miles per hour for that. Next, looking at lightning, and we see quite a lot of lightning around North America right now. Southern Mexico especially, but also some storms in the central U.S. as there is an atmospheric river formed. We'll show you that momentarily. And if you're in Topeka or Kansas City, if you're in Kansas City, look to your southwest. You may see some interesting phenomenon occurring above these thunderheads, as there is some very energetic lightning going on. And if you're in Topeka, look to your south. And if you're in Emporia, there's thunder rolling in. It's a real-time lightning map, lightningmaps.org. Lightningmaps.org, powered by blitzachtung.org. And check out all the lightning here, a long line of lightning all the way from Nebraska to southern Mexico. The most intense is at southern Mexico. This is your NASA GOES lightning mapper. And we'll show you what's going on with that in a little more depth. First, we're going to do a temperature forecast. I thought we were going to do a temperature forecast. All right, so here's the current temperature situation, and we're going to advance this into tomorrow. This is the forecast by Copernicus, I guess. Okay. That's 12 noon tomorrow, 12 noon Eastern Daylight Time tomorrow. For temperature, as reported by windy.com. We're also expecting some flooding here in East Texas. So this is the forecast model from Tropical Tidbits for total accumulated precipitation through Friday. And you can see they're forecasting like 20 inches of rain there in East Texas and southeastern Oklahoma. Let's hope that forecast changes, as that would be, let's just say, unhealthful for all kinds of various different phenomenon. I'll just rock this back to show you how this is forecasted to play out currently. So some major flooding forecasted there later in the week, especially Wednesday, Thursday, and Friday. Some persistent rains forecasted for that area. And keep in mind that forecast is way out. A 3-day forecast is much more accurate than a 5-day forecast like that. And here's what's going on in the current situation for the U.S. Doppler radar. Strong storms across Kansas and Nebraska. Very strong storms there across Kansas, especially. We're hoping nobody ends up in Oz as a result of those. Keep in mind, folks, the most dangerous part of a severe thunderstorm in the northern hemisphere is the northwest corner of the storm. Here's what's going on in the cloud layer, and you can see that atmospheric river stretching all the way from Mexico to South Dakota, actually. And here's the water vapor map. This should help clarify things. And the jet stream, what's happening here, folks, is the jet stream is way over here. And it's not really helping to drive this system much at all. It's creating a weak low pressure system behind the jet stream there, the leading edge. And that's why this atmospheric river is taking its good old time moving to the east. This dry mass of air is not providing much of an impulse either, although it isn't colliding much, as the air ahead of it isn't all that dry. So again, there's the U.S. Doppler radar map. Here's the cloud layer. And there is the water vapor map. And it's time to say goodbye to Twitch again. We'll complete our daily space weather video with our bonus of features. So make sure you check it out, Twitch viewers, at youtube.com/smAshomash. Here come the bonus features. And the first thing we're going to show is the hydrogen alpha imagery from the ground-based solar observatory at El Teide, Spain. So here's the newest data from that. You can see some filaments extending out over the limbs, as well as some darkened spots here. Those are the filaments in front of the limb. So there are some filaments, folks. We still could see additional coronal mass ejections here. Likelihood of large solar flares has gone down with the degradation of sunspots. But again, we don't really need solar flares or sunspots to see coronal mass ejections. Here's the intensity gram. And again, only one sunspot group currently, sunspot 2822. The rest have all degraded to plages. Here is the magnetic field scenario for sunspot 2822, the only sunspot currently on the Earth-facing portion of the solar disk. Next, I'd like to thank our patrons, a true source of funding for the content. Please consider becoming a patron, increasing the probability that these videos will continue to exist. Patreon.com/smAshomash if you want alerts earlier than everybody else on Earth. Alerts for things like coronal mass ejections before they even leave the solar corona. It might be beneficial for you to have that information. Who knows? But in any case, patreon.com/smAshomash. Thanks again to our patrons for making these videos more likely to continue to exist. And last but not least, here are some more images of the closest star. Here's the northwestern corner. Some great filamentary activity visible there. And here's a close-up of Sunspot 2822. Thanks again for tuning into the Daily Space Weather, folks. Remember to stare at the sun, attempt to understand the physics, don't drink, and if you do, don't drive. I don't care if you drink, just don't drive. Once again, welcome to the Neo Renaissance. Visit our sites, support our channel, please. Thanks again to our new subscribers, etc. And may that solar wind be at your back. This daily space weather video brought to you by the Smash News Network. Least busted name in news.